problem slightly different from most of my videos. I usually like to just show one way of doing a problem, so that way if somebody comes to office hours I'll show them multiple ways, of course. But in this example, I think with this one and with the associated rational expressions, there's two really nifty ways of doing this. One kind of bases it on the practicing of the arithmetic that you already know for fractions, namely that when you add and subtract fractions you need common denominators. So that approach is to look at this 1 here and treat it like a 1 over 1, and to think of the common denominator between 1 and 2, which is of course the number 2. And similarly on the bottom, think of this as 1 over 1. The denominator is a 3 for the 2/3, so you introduce a 3 and a 3. And so in the top we have 2, what do we have here? We have 2 halves plus 3 halves. That's a total of 5 halves. And in the bottom we have 3/3 minus 2/3, which is 1/3. And so that was getting common denominators to add or subtract the fractions. And then when you're dividing by a fraction, that's equivalent to multiplication by the reciprocal. So in the next step you can say this is 5 halves, and instead of dividing by 1/3, it's multiplied by 3 over 1. 5 times 3 is 15, and 2 times 1 is 2. So that yields a final answer of 15 halves. The alternative method, which I think is very smooth, takes a little bit more thinking on the side though, is that when you see that 3 and the 2 that are the denominators inside of the expression, in the numerator has a denominator of 2 and a 3 in the bottom, you can just multiply by the LCD of those denominators, which in this case would be LCD of 2 and 3, which is just 6. So I'm doing 6 on top and bottom. Now watch what happens when we distribute here. 1 times 6 is 6. 3 halves times 6 is, 6 divided by 2 is 3, and 3 times 3 is 9, over 6 times 1 is 6, and here 6 divided by 3 is 2, and 2 times 2 is 4. So now we have, well, what do we have? 6 plus 9 is 15, and 6 minus 4 is 2. The exact same answer. So this one takes a little bit, the one on the right takes a little bit less work, but takes a little bit more thinking, and the one on the left is more very mechanical, following the traditional rules. So why don't we pause the video here and try to do one of these on your own, and assuming you gave it a shot, you could do whichever one you like best. I'm going to model both just in case. So here with the numbers, let's see, our denominators on the top are 3 and 5. So I'm going to insert a 5 top and bottom here, 3 top and bottom here. For the bottom we have a 2 and a 6, so I'll have to throw in a 3 on this one. I don't really need to worry about the 5/6. And so now what do we have on top? But we have 10/15 minus 6/15 over 9/6 minus 5/6. Okay, so top 4 over 15 divided by bottom 4 over 6. And then we can multiply by the reciprocal. So 4/15 multiplied by the 6 over the 4. The 4's clearly reduce. 6 and 15 have a common 3 that goes into both of them. So we end up getting the answer of 2/5. Now on the other hand, the LCD of all of the denominators, 2, 3, 5, and 6, would be, let's see, probably a 30, right? 30. So when we pull it in on here, 30 divided by 3 is 10. 10 times 2 is 20. 30 divided by 5 is 6, and 6 times 2 is 12. 30 divided by 2 is 15, times 3 is 45. And 30 divided by 6 is 5, times 5 is 25. So let's see if this was easy also. Let's see, 20 minus 12 is 8. 45 minus 25 is 20. And a common number that goes into both 8 and 20 would be 4. What's 8 divided by 4 but 2? And 20 divided by 4, which is 5. So again, similarly, we get the exact same answer of 2/5.